In this video, I'm going to talk about modeling as a process and give you an overview of that process. So the first thing you want to understand up front is that what modeling is. It's about having standard notations for how you're going to model, how you're going to document and communicate decisions that you've made. The modeling helps us understand requirements and design thoroughly. So remember, modeling as a process can be in requirements and it could be in design. The idea behind modeling is that you want to be able to understand that, look here, and find that the holes exist in your understanding. So it's all about revealing holes in understanding, and that gives rise to unknown or ambiguous behavior. Multiple conflicting outputs to the same input reveal inconsistencies in, say, requirements. So as an overview, here are some models I'll go through in some subsequent videos. I won't do it in this particular one, but I want you to understand that there are modeling diagrams and there are different ways of doing these same kinds of models. So for example, ER diagrams might be implemented as a UML class diagram rather than just a generic ER diagram. State machines might be done using the generic state machine type diagrams, or the UML state chart diagrams, which are a particular way that you could draw state machines. Metrinets is another way you could draw a state machine. So there are multiple ways of actually drawing it, and there are different ways that different sets of modeling notations give rise to it. There are other modeling notations in addition to those, function relations, logic, algebraic specifications. These are a whole bunch of other type modeling notations I'm not going to concentrate on. I just wanted to get a sense that that the ones that I talk about aren't it. There are lots of them out there. Some that you may like, some that you may not like, some that are better suited for requirements, some are better suited for design, some are better suited for late design as opposed to early design. There are different trade-offs between all of the different kinds of modeling notations, and the reason that all of these existed because somebody thought that this was important and useful in actually trying to figure out where the holes in my understanding. And you have to remember that this is about communicating those holes, about when you draw these models, about when you create them and you actually try to use them and communicate them to someone else outside of you, that you will discover a hole in your understanding. It's all about discovering those holes in your understanding, and they may seem like a lot of work up front, and it may seem that, okay, somebody just wants me to draw this thing, but why am I doing this? It's just a waste of time. The reason that you're going to be drawing it is so that you're going to have to use it and communicate it to someone else. If you have not taken the model and explained it to someone else, you have wasted your time. That is the reality of it. Don't waste your time. Actually use the model and actually try to communicate it. Now, in the communication of it, in documenting and in communicating it, you will find a hole, probably. If you haven't, well, all good, you probably understood it, but you have to allow the other person to ask you questions about your understanding, about why did you draw it this way, and what did you actually mean by that. And in that interaction, you'll discover ambiguities, hopefully. So here are some other models we've probably encountered before. We would have probably seen like block diagrams. Those are great for showing structure and modules, and can give like modular decompositions and that kind of thing. Flowcharts are very popular. You can just use it to describe a process that you've uncovered during requirements. You could use it to describe a process that is how code will operate later on in design and that kind of thing. It's all about how you apply it. Pseudocode and algorithms, those will probably come where you're talking about the steps in code and that kind of thing. Algorithms can be used to show steps and that kind of thing up front in like requirements, but that's usually when you're modeling a process. And you're trying to model a high level type process. You don't want to get down to the details that you're really talking about how. Just remember, in requirements, the models are supposed to extract what, and in design, models are supposed to extract how, and that's how you're going to be applying them. That being said, as I alluded a little bit earlier, there are things called modeling languages. Modeling languages are groups or collections of models, and a lot of the times, a lot of the generic models that exist, modeling languages have specific ways of how they implement some of those models. So for example, there are at least three modeling languages that I'm highlighting here. That's UML, the Unified Modeling Languages, SDL, and RML. UML is probably one of the more popular ones amongst them. And remember, these modeling languages host a whole bunch of different ways of doing things, and may or may not implement some of the generic models that exist. So the Unified Modeling Languages, that's the UML, it combines multiple notation paradigms. There are 8 graphical modeling notations, as well as what they call the OCL constraint language, and they have all of these and more. So that's like use case diagrams. That's a high level DFD type diagram, a class diagram, which is a type of ER diagram, a sequence diagram, or an event trace. So it has all of these kinds of things, and you see that there's a sequence diagram and a collaboration diagram. Those are both a type of event trace, really and truly, right? You'll come across what event trace and that kind of thing in the later on videos. So just get an idea that I just wanted to get an idea that these modeling languages allow you to draw models in specific ways, and they usually have reasons for why they draw it in specific ways. So here's an idea of where you could use certain diagrams from UML. If you choose UML as your modeling language, you could use some of those diagrams in the different forms. So during requirements, you can use like use case diagrams and UML activity diagrams to model scenarios and domain models during requirements. When you're doing the design of your architecture, your high-level architecture, you could use, say, UML component diagrams or even deployment diagrams. And when you design phase, you could probably focus in on like class diagrams, object diagrams, package diagrams, and all of these different types of diagrams during that process. So here's now the specification and description language, that's SDL. So another modeling language if you don't want to go on the class of UML. This was created by the ITU, that's the International Telecommunication Union, and it specifies the behavior of real-time concurrent distributed processes that communicate with each other via unbounded message queries. And here are some of the types of diagrams that you'll encounter if you're trying to use SDL. They have lots of DFDs, they have a lot of event traces as well as some state machines and some others. So that's often accompanied by a set of message sequence charts, or message sequence charts, if you don't know, are a type of event trace. Okay, so what's beyond this? So there are lots of other modeling techniques that I won't probably mention in this course. Some techniques include facilities for associating a degree of uncertainty or risk with each requirement, and that's sometimes important, especially when you're doing risk analyses and these kinds of things. Like say if you choose like a spiral approach, or you're just doing any kind of risk reduction technique. Other techniques which have facilities for treating requirements to other tracing requirements to other system documents, such as design or code, or to other systems, such as when requirements are reused. I'll show you one technique for that when we're talking about requirements management. Most specification techniques have been automated to some degree, making it easy to draw diagrams, collect terms and designations into, like, say, a digital dictionary, and check for obvious inconsistencies. As tools continue to be developed to aid software engineering activities, documenting and tracking requirements will be made easier. However, the most difficult part of requirements analysis, that's understanding the customer needs, is still very human. These diagrams won't really help you much in understanding their needs. You have to remember that they have to be used in tandem with some kind of process that you're using at the higher level. A tool will never ever replace a process at the end of the day. Okay, so I hope you have a rough idea about what modeling is generically at this point. Tune into the other videos where I'll kind of go a little bit more in depth into each one of the types of diagrams that exist, and from there I will just take it from there. Okay.